Magandang araw, magandang gabi, magandang umaga Pilipinas at sa lahat ng mga kababayan natin saan mang sulok ng mundo kayo ngayon. Kumusta ho? Pagpatuloy ho natin yung last video natin, karugtong ho ito ng series about deuterium. So, last time na pag-usapan ho natin yung last portion na merong from Butuan na scientist, si Dr. Cano, na ang kanyang theory dahil heavy molecule yung deuterium nagsisink in sa tubig. Ngayon, titingin tayo manonood tayo ng experiment kung tama yung kanyang theory, Dahil yun ang theory ngayon yung Surigao Deep, dahil yung deuterium is abundant sa ocean, pero nasa ocean floor. Ngayon, kailangan na i-explore yun kung talagang mataas yung concentration ng deuterium sa Surigao Deep. Dahil yun ang gusto nating malaman dahil kung mataas nga naman ang concentration doon, with all the experiment na ginagawa ngayon on nuclear fusion, kinakailangan nila yung deuterium. So, if we can supply the deuterium in large amount, then, we are in good shape. So, let's find out to. Again, ito a community discussion. It's a forum na pag-usapan natin kung ano ang saan tayo nalalagay. Okay, so, panoorin ho natin itong video. It's about saan na-form yung anong na-form sa ilalim, dahil yung deuterium it should go through yung extraction should go to a process na tinatawag na electrolysis. Yung electrolysis requires salt water and some kind of material na ginagamit as a fuel cell. Ngayon alam natin na yung tubig sa dagat salty yun, may mga ibang chemical components yun. So panoorin natin itong video na to about what goes in the deep. They mention about hydrothermal spring, yung mga black smokers sa ilalim na pinapainit yung tubig. So that's one process of electrolysis. Pinapainit yung tubig, tapos magse-separate yung deuterium from hydrogen. Okay, let's watch this video.
Smokers on the sea floor bring up valuable raw materials from inside his readers on an adventurous diving trip. His vision is about to become reality. Black smokers on the sea floor bring up valuable raw materials from inside the earth. Their meter-high vents seem to give off clouds of smoke like underwater industrial chimneys. Marine geologists from GeoMar, Helmholtz Center for Ocean Research Kiel, examined those vents and took samples back to their laboratories. They aim to find out which chemical elements make up the rocks. Thus, they can draw conclusions on the formation and evolution of the black smokers. These vents are not only interesting for research purposes, but also for the industry. This is due to the chemical reactions taking place when seawater is heated up by magma chambers. Hydrothermal vents occur on the boundary of the tectonic plates all over the world. Here, seawater flows into the ocean floor through cracks. At a depth of 2 to 3 kilometers, this water is heated up and then rises to the surface under great pressure. On the way up, the pH and the oxygen content of the water decrease. The resulting aggressive and up to 400 degrees Celsius hot fluid leaches out various elements from the surrounding rock. When coming in contact with the cold seawater, minute particles are formed, causing the escaping water to look like smoke.
So, 400 Celsius, that's very hot, So, luluto dito yung ito yung process ng tapos magfo-float.
vicinity, substances are deposited and vents are formed. A geomar expedition to the mid-Atlantic ridge.
Okay, so yan ho, napanood natin kung ano yung nangyayari sa ilalim, ano. So pinapollow up lang natin yung theory, yung conclusion, ano, kung what's going on underneath. So ibig sabihin may mga magma, may mga hydrothermal springs sa ilalim sa deep trenches. So ang tubig doon madilim na, hindi naabot ng liwanag ng araw yun, ano. So supposedly malamig. Pero because of the hydrothermal spring, yung mga black smokers, they found out na pinapainit yung tubig. So yung tubig, pag napainit yun, it's ready for electrolysis. Okay, so ngayon, the interesting theory na malamang doon sa deep trenches is high ang concentration ng deuterium dahil heavy molecule nga ito. Panoorin natin itong video about what's this called? Itong experiment sa laboratory. This is a laboratory.
Okay, so we're going to do an experiment today.
Periodic videos. Okay, so let's watch this.
Okay, so we're going to do an experiment today that Martin Polyakov has been on us to do for a while. So we're finally going to get around to doing it. He's very excited about it. And what we're going to talk about is deuterium oxide. Okay, so deuterium oxide is often referred to as heavy water.
So this is a preserved na ito na nilagay na battled na deuterium. So nakapag-produce ng deuterium. It's produced in the lab. So alam na natin yan dahil back in the 1930s na basa natin yung article that certain scientist named Urey was able to produce it, 5 liters of liquid nitrogen na naka-extract sila ng 1 ml na deuterium. Okay, let's move on.
Exist in more than one form, which are chemically identical, but where the atoms weigh different amounts. And the difference between these different forms, which are called isotopes, is by far the biggest for hydrogen.
So it's heavy water. So water is H2O, as I'm sure everyone knows, and deuterium oxide is D2O.
So hydrogen normally has one proton, but a second form of hydrogen called deuterium has a neutron as well. The neutron has the same mass as the proton, but is electrically neutral. It doesn't have a positive or a negative charge. The proton has a positive charge. So you can add this without affecting the atom. You still have just one electron. So it's just like hydrogen, but now you can see it weighs twice as much.
So hydrogen is just a proton with a little electron buzzing around it, if you like, and deuterium is a proton and a neutron with an electron buzzing around it.
In the universe and on the Earth, about one atom in every 7,000 of hydrogen is in this heavy form, deuterium. This means that if you are an average weight adult of about 70 kilos and making an assumption of about how much water is in your body, somewhere between 6 to 8 grams of the water in your body is in fact heavy water, which contains deuterium instead of hydrogen.
Neil's dug out a really old school sample of deuterium oxide. So I like the box. I finally worked out how to open it, which is good. And what we have is a really, really old school sample. Look at the writing. It's all kind of like, I don't know, it looks like 1930s.
By the way, itong deuterium oxide na to na preserve, naalala nyo, binanggit ko, the first country na merong manufacturing company or manufacturing station na by chance nakapag-produce ng deuterium. Isa sa mga ginawa ng film kasi yun, ginawa ng movie. Isa sa mga cast ng movie, yung kanyang, I think, grandfather was part of the crew. Pagkatapos ng show, binigyan siya ng parang anong tawag dito, parang memento ba, para i-preserve niya at binigay niya sa professor na ito, and this is what it is now, and they're trying to create something off of it.
Writing or something. I'm not quite sure how old it is, but it's a really old sample of D2O, and it's sealed in a glass ampule so that it kind of remains as it is in there.
Where do you get all that stuff, Neil?
So you can imagine water, which is H2O, has these heavier atoms of hydrogen, which have their own chemical symbol. So instead of being H2O, it's now D2O. And you can also, as in your body, what you will have is just one hydrogen and one deuterium, because you've got so much water. And the hydrogens and the hydrogens and the deuteriums can switch around between one molecule and another. But if you're really careful and do a careful separation process, you can get pure D2O.
So today's grand experiment is we're going to make, well, we've made some ice cubes with normal water and some ice cubes of D2O, okay? So we got an ice cube tray, which we're going to dig out in a minute, and we've actually just made some normal ice cubes. And what we're going to do is, it's an experiment I've never actually done before. We're going to see if the, obviously you know that water, so ice, because it's less dense than water, actually floats in water. And we're going to look to see if we make D2O ice cubes, whether they will float in the water or not, because obviously deuterium oxide is a bit denser than water because it's heavier.
D does not appear on the periodic table, but deuterium is used so much in all sorts of chemical experiments that it has its own symbol. In fact, there is a third form of hydrogen which has 2 neutrons, so its weight of 3 units, called tritium, which has the symbol T. But tritium is radioactive, so it's not used very widely unless you're trying to make nuclear weapons, and that's another story.
But what we need to do first is we need to get rid of all the air, because obviously there's a lot of air dissolved in D2O, in anything. So Neil has degassed some D2O and some water for us. So this is a vacuum pump here, and what you can do is apply a vacuum to said liquid and pump out all of the air out of the liquid. So we're degassing it. There we go. So what happened was that the air basically started to almost, if you like, boil out of the water.
For a long time, I can't remember how long, but more than 30 years, it has always struck me that ice, solid water, is about 10% lighter than liquid water. That's why ice floats at the top of your drink or floats on the top of the pond in your garden.
Okay, so what we did was we made some ice cubes with the degassed water. So these are the water ice cubes, the colourless ones. And what we did with the D2O ones, just so we could see the difference, is we put a little tiny bit of food colouring, only a small amount, so it shouldn't affect the experiment at all, but it's just so we can see the difference. Okay, so what we need to do now is fill these beakers with water, so we'll get some water.
The question is, since D2O is 10% heavier than H2O, heavy ice, solid D2O, should be just about the same density or perhaps slightly heavier than liquid water. So it might be that heavy ice should sink in liquid water, in ordinary water. And I've always wondered what happens, and I've never been able to do the experiment.
So what I'm going to do is, I hope this works, is pop a D2O ice cube in here, and I'm hoping it sinks.
Boom. Wow. So, Dr. Cano was right after all. That deuterium, since it's heavy, it's gonna sink down to the bottom. And that's exactly what we are seeing in the laboratory. Okay?
Yeah, I think that's sunk.
I now know that my colleagues have done it, but I have no idea what's happened. My prediction, and I've done lots of calculations, is that it'll just sink. But I might be wrong. I might have forgotten to include something in my calculation.
So what we've got is we've got ice in water here, and ice is less dense than water, so it's floating. And in this one, we've got the deuterium oxide ice, so frozen deuterium oxide, and that is denser than the water, so it's sunk to the bottom.
We did the experiment, and the D2 ice did sink.
It did sink. So, yes. Wow. So, there it is. It sink. So, alam natin na yung hydrothermal spring, there's enough heat to potentially cause electrolysis. Now, yung pressure coming out from the magma heat, ipupush yung tubig sa taas kasi light yun, yung hydrogen. However, yung deuterium is heavy isotope. So potentially, it would just fall back into the deep trenches. So now, yung mindset ni Mrs. Imelda Marcos at saka ni President PPM that we must explore and check the possibility kung meron nga. Okay? So, anyway, that's very interesting. I hope that triggered a little bit more interest on you. Sa susunod, pag-usapan natin yung area na ilan ang na-produce nila noon na nagkagulo ang mundo because of that. Inattack ng Germany itong country na to para makuha lang itong manufacturing plant. And they can get hold of this heavy water production. At in-increase nila yung production dahil gagamitin nila for their atomic pump. This was back in the 1930s. Very interesting. So, next na video natin, ipapasok natin yan. No? So, na-produce yun. So now, dadagdag ko with the ongoing initiative with nuclear fusion study. There's billions of fundings that's being put in right now. Habang piniperfect nila yung technology kung paano mag-produce ng energy through nuclear fusion fueled by deuterium and tritium, it makes sense na tayo mag-explore the possibility of extracting a concentrated large amount of deuterium para i-supply. Dahil once that they perfect the technology, these countries are gonna need a huge amount of supply of deuterium. So, tapusin ko lang ho itong second video rito at next video natin, we have more interesting information na isi-share natin. So, again, katulad ng nabanggit ko sa unang video, this is like a community forum. Pag-usapan ho natin, wag ho tayong mag-argue, wag ho tayong mag-debate. Gusto lang naman natin i-explore, gusto lang natin maintindihan kung ano ba talaga, truth or hoax, anong potentials, anong maaring mangyari, you know, sa investment ng stocks or particularly sa options trading. There's always this principle, risk versus benefits ratio. Nag-wager ka ng 100, tapos yun ang risk mo, to lose 100, tapos ang ratio ng benefit mo is let's say 101 lang. Tanong doon, is it worth waging 100 versus 1? Or kung halimbawa nag-bet ka ng 100 sa stocks, pero ang potential yield mo is 200, risk and ratio rewards. Of course, you would want to put that bet right there. So, close ko ito. Magandang araw ho sa inyong lahat. Hopefully, this video will find you in a safe and happy place. Stay safe and happy ho. See you in the next video.